Okay, topic 2, positive and negative numbers. That's exciting. Let's get going. Question 1. Altitude above sea level is given in positive values, and below sea level is given in negative values. Which situation describes a hiker in Death Valley stopping at an altitude of 0 feet? Okay, here you have the classic Death Valley positive and negative number question. So Death Valley is a valley where the bottom of the valley is below sea level. So here you can see as the green line represents the hike. You can have a little hiker, hike down below sea level. That's fun. Okay, this question comes up a lot. Let's try to work through it. So let's say so what's the actual question again? Which situation describes a hiker in Death Valley stopping at an altitude of 0 feet? Okay, so let's work from the bottom up. D, the hiker starts at 0 feet, then decreases his altitude by 10 feet. So start at 0, decrease your altitude by 10 feet, you end up at negative 10. That's not 0, that's not right. You're out of there. C, the hiker starts at 10 feet, then increases altitude by 10 feet. So if she starts here and then increases her altitude, she's going to go up to 20. So that's not ending up at 0, so that's not right. The hiker starts at negative 10, then decreases her altitude by 10 feet. So you start at negative 10 and you go down. Well, that's not going to end up at 0, so that's no good. And finally, A, I hope this one works out. The hiker starts at negative 10, then increases her altitude by 10 feet. Starts at negative 10, increases her altitude by 10 feet. She ends up at 0 feet. That's what we're looking for. Start at negative 10, increase your altitude by 10 feet. You end up at 0. Bingo, we're good to go. Okay, question 2. What is the value of the expression below? You have 3/8 plus negative 4/5 plus negative 3/8 plus 5/4. Whoa, that's a lot of work. But wait, look at this. You have 3/8 plus negative 3/8. That just cancels out, right? You can use the commutative property of addition to add numbers in any different order. Remember, that's the property of addition that says 2 plus 3 equals 3 plus 2. It doesn't matter what order you add numbers in. So 2 plus 3 plus 1, that's going to equal 6. And you can add them in any order. So that equals 1 plus 3 plus 2. It's still going to equal 6. So if we have 3/8 plus negative 3/8, that's just going to cancel out. And then we can have plus negative 4/5 plus 5/4. But this 3/8 plus negative 3/8, that's just going to cancel out. Boom, boom. We're left with some work to do. But we're off to a good start. Okay, so we have negative 4/5 plus 5/4. Kind of giving away the answer here. But first, what we have to do in any addition of fractions is we have to get a common denominator. And what's a good common denominator between 5 and 4? That's right, 20. So let's make negative 4/5 into something over 20. Well, we know 5 times 4 gets you 20. So negative 4 times the same thing, because whatever you do on the bottom, you got to do the same thing on the top, will give us negative 16. So that's negative 16 over 20. And 5/4, well, let's multiply each by 5, because 4 times 5 gets you 20, and 5 times 5 gets you 25. So here we go. After we do that, we have negative 16. Let's clear it up a little bit. We have negative 16 plus negative 16 over 20 plus 25 over 20. Negative 16 over 20 plus 25 over 20. How do we make sense of this? Well, if you look at it on a number line, which is always helpful, you can say we have negative 16 plus 25. So negative 16 plus 25 is going to give us a positive number. And we know the denominator is going to be 20, right? Because that's the way adding adding fractions works. So we know negative 16 plus 25 is going to give us a positive number. And if we think of 25 as using 16 of those 25 to get us back to 0, well, how much do we have left to get us to positive? That's like 25 minus 16, because we use up 16 of the 25 to get back to 0. And how much do we have left? We have 9 left, because 25 minus 16 is 9. We have 9 left to go positive, so that'll end up at positive 9, and our answer is going to be 9/20. Our answer is going to be 9/20. Question 3. Yesterday, the temperature at noon was 11.4 degrees. By midnight, the temperature had decreased by 15.7 degrees. What was the temperature at midnight? So what do we have? We have the temperature starting out at 11.4 degrees and then decreasing by 15.7 degrees. So it starts off at 11.4 degrees and it decreases 15.4 degrees. If you look at your answers, well, what could it possibly be? You know the answer is going to be negative, right? Because it goes 11.4 minus 15.7. It's more, 15.7 is more than 11.4, but just by a little bit. So the answer is going to be just a little negative. And you can use estimation to be pretty confident it's going to be A. But what if this was a constructed response? We have to know how to get the answer perfectly, right? So if this was a constructed response where we weren't given A, B, C, D, we weren't given the multiple choices, we still need to know how to do the math. And just as before, we can say out of this out of 15.7, decreasing 15.7, how much of it do we need to get back to 0? Well, we need 11.4 of it, right, to get back to 0. So we're going to need 11.4 of it to get back to 0. And everything else we have left is going to be as much negative as we go. So another way to do that is to take the difference between 15.7 and 11.4. So let's just do that. Let's just do 15.7 minus 11.4. 7 minus 4 is 3. Bring down the decimal point, and 5 minus 1 is 4. And the answer is going to be, we have 4.3 to go from 0 to negative. The answer is going to be negative 4.3. And you might know of the rule that when you have two numbers like this, that you add the opposite. You can always add the opposite. And if you have 11.4 plus negative 15.7, you know your answer is going to be negative, because negative 15.7 is bigger on an absolute value basis than 11.4. How much is the answer going to be? How much negative are you going to go? We'll just get the difference. So that's what it means by the rule of keep the bigger by absolute value basis, and subtract and get the difference through subtraction. So keep the bigger, so it's going to be negative, and get the difference. But here, I just draw it out on a number line so you can be clear as to what you're doing. You have 11.4, you'll lose 15.7. You know your answer is going to be negative because 15.7 is more than 11.4. And how much negative are you going to go is how much you have left of 15.7 after you get back to 0 by subtracting 11.4. So your answer is going to be negative 4.3. Okay, question 4. What is the product of negative 1/4 times negative 3/7? We need a rule. The rule, and you probably know it by now, is a positive times a positive equals a positive. A positive times a negative equals a negative. A negative times a positive equals a negative. And a negative times a negative equals a positive. Works the same exact way for division. The basic rule is if you have one negative, your answer is going to be negative. If you have two negatives, your answer is going to be positive. Because for every negative sign you have, you flip the number line. So if it's negative times negative, you're going to get positive. That's what we have here. We have a negative times a negative, so we know our answer is going to be positive. We can get rid of these negative answers. Negative 1/4 times negative 3/7. Well, we know the answer is going to be positive, so we don't have to worry about the negative signs. all we have to do is simply multiply on top. 3 times 1 is 3, and multiply on bottom. 4 times 7 is 28, and we get 3/28, and we're good to go. Okay, question 5. Scientists determined that Antarctica's average winter temperature was negative 34.44 degrees Celsius. The difference between this temperature and Antarctica's highest recorded temperature was 49.44 degrees. What was Antarctica's highest recorded temperature? All right, so what do we have? We have a temperature problem, and you should always draw number lines when you have a temperature problem. Here, we have the average low temperature of negative 34.44 degrees, conveniently located below zero. Now we have the difference between this average low temperature and the highest temperature ever as 49.44 degrees, and we are tasked with finding out where on the number line this dot is. And just by drawing it out, we know we have negative 34.44, and we have that plus, because the highest temperature is higher than the average low temperature, or the average temperature. The highest recorded temperature is always going to be higher than the average temperature. Obviously, the highest temperature is going to be higher, right? So you have negative 34.44 plus 49.44, and that'll get us to the answer. So how do we do this? Traveling through zero is difficult, but if we know that we're going 49.44 and we're using 34.44 to get back to zero, what we have left will take us to our answer. So if we're using 34.44 of this amount to get back to zero, the rest will take us to our answer. So all we have to do is find the difference between 49.44 and 34.44. If you use subtraction, you'll find the difference is 15. So we know we have 15 up from zero to go to our final answer of positive 15. And we're good to go. Okay, next one, question 6. What is the value of this expression? 8 over 15 divided by negative 0.35. And you're like, oh, what's my rule? So let's go back to the rule. The rule is, positive divided by positive is positive, positive divided by negative is negative, negative divided by positive is negative, and negative divided by negative is positive. We know this, we've memorized it, we're good to go. And what we have here is a positive divided by a negative, so we know the answer is going to be negative. Okay, and all right, well, that does us absolutely no good. That's no help at all because all our answers are negative. Okay, so we can't eliminate any of the distractors, but that's fine because we still have work to do. So we have 8 and 8/15 divided by, let's just forget about the negative and just say 0.35. And what do? Well, we got to convert one of these numbers to the other form, right? Because we can't deal with fractions and decimals. We have to deal with fractions and fractions, or decimals and decimals. And because all our answers, bling, 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 are in fractions, I think it's a lot easier to work with fractions. So let's just turn this into a fraction. Well, 35 hundredths is the same as this, as we've known through years of math. 35 hundredths, maybe we've forgotten because we're doing really complicated stuff, and sometimes we forget the stuff we've done previously, but you should remember, now that I show it to you, hopefully it clicks in if it hadn't before, that 35 hundredths is the same as 35 over 100. I know now we're dealing with negative numbers and it gets all weird, but 0.35 is still 35 over 100. And if we do that and we want to simplify, well, we know we can just divide by 5, divide by 7, divide by 5, divide by 7, divide by 5, divide by 5. I'm getting ahead of myself here. You get 35 divided by 5 is 7, and 100 divided by 5 is 20. So you have 8 over 15 divided by 7 over 20. And we're good to go. We can just run our algorithm of keep, change, flip. So we're going to keep 8/15. We're going to change the division to a multiplication. We're going to flip 7/20 to 20 over 7. And we can multiply on through. And we get 160 over 105, and we know that we can divide each of these by 5 because you know, it ends in 0, ends in 5, and 105 divided by 5 is 21, and 160 divided by 5 is 32. So we know our answer is going to be negative 32. Don't forget the negative sign because that's up from here, right? Negative 32 over 21, and we're good. All right, question number 7. Which expression is equivalent to 4 minus negative 7? 4 minus negative 7. We have 4 minus negative 7. And what we got to know is we got to know the rule. The rule is that whatever number minus a negative number equals that number plus that number. You just got to know it. You just got to know it. You can think of it as adding the opposite, but a number minus a negative number equals that number plus the second number. So here we have 4 minus negative 7, and that's just going to equal 4 plus 7. Minus a negative is the same as plus. 4 plus 7, and we know that's going to equal 7 plus 4 because of the commutative property of addition. It doesn't matter what order we add numbers up. 7 plus 4 equals 11, just as 4 plus 7 equals 11. Everything else doesn't even come close. Don't get fooled by this one. This would be negative 7 minus 4 would be negative 11, and everything else just isn't close. Your answer is A. We're good. All right, question 8. Question 8 is really tough. Remember question 7? That was fun. That was easy. Now we're on to a really tougher question 8. And you're like, oh, why is it going to get tougher? And you're like, oh, you're taking this test. You might be taking it for a long, long time, and you get an easy question, you get an easy question. You're like, oh, I know how to do this. And then you get a really tough one. You gotta muscle through it. You just gotta keep plowing ahead. You can do this. You know all the individual steps. You just gotta put them together into a big long march to get where you want to go. But here we are. What is the value of the expression below? Negative 0.75 minus a negative 2/5 plus 0.4 plus negative 3/4. Hey, and your answers are all in decimals. So like, I have decimals, I have fractions, my answers are in decimals. I should change my fractions to decimals. That's a good first step. And after you do that, it's going to go get tougher and tougher and tougher, but we can get through this. Okay, so let's do it. First, we have 2/5 and 3/4, right? Because we want to change 2/5, and we'll deal with the negative in a second, but we want to change 2/5 to a decimal and 3/4 to a decimal. So how do we do that? Well, let's get them over 10 and over 100, because that turns numbers into decimals, doesn't it? 5 times 2 is 10, so whatever you do to the bottom, do the same thing to the top. 2 times 2 is 4. 4/10 equals 0.4, because that's 4/10. We should remember that. It should be pretty clear to us that 2/5 equals 4/10 equals 0.4. Okay, 3/4. Well, 4 times 25 gets 100, so 3 times 25, we'll multiply 3 times 25, because whatever we do to the bottom, we do to the top. And again, 75 over 100 equals 0.75, because this is hundredths, right? 4/10, tenths place, and 4/100ths, the hundredths place. Now, if you had a calculator for this question, which you may or may not, you could always do 2 divided by 5, right? Because this 2/5 is 2 divided by 5. And what will that equal on your calculator? We'll be shocked to know it'll equal 0.4. So that's a good way to do it if you have a calculator for this one. And then same thing, 3/4 is 3 divided by 4. And if you do that, you will surely get 0.75. Okay, so that's how we take the fractions and turn them into decimals. And here we go. Let's rewrite it as negative 0.75 minus negative 0.4 plus 0.4 plus negative 0.75. Okay, that is what we have to deal with. That is what we have to deal with. And as you see, the first 2 lines of this next page just have it rewritten for us. So let's get going here. That's the original, and we shift out the excuse me, we shift out the fractions for decimals, and here we are. Now, what do we have? What do we have with this minus the negative, right? What do we have with this minus the negative? We've just found out, and we just went over it, that the rule is minus a negative equals adding a positive. Minus a negative equals adding a positive. We keep the first same number, we minus a negative, we get to add a positive. Okay, so we keep the first same number, it's negative 0.75. We minus a negative, what do we get? That's adding a positive. So that becomes, minusing a negative becomes plus 0.4. We keep going, we just bring the rest of it down, 0.4 and plus negative 0.75. Okay, well, what can we do now? If you remember the commutative property of addition that we just talked about, we can shift the order around, right? We can move the positives to one side and the negatives to another side, because 1 plus 2 plus 3 equals 3 plus 2 plus 1. So let's do that. Let's bring the positives over here and bring the negatives over there. We have positive 0.4 plus positive 0.4 plus negative 0.75 plus negative 0.75. And you really want it to be like positive 0.4 minus or plus negative 0.4, so they can cancel out and become 0, but they just don't. You have 0.4 plus 0.4 plus negative 0.75 plus negative 0.75. If you have negative 0.75, just move it over. And there we go. So what can we do with that? Well, let's add them together. We should be able to add 0.04, and this is the associative property of addition. We should be able to add 0.04 plus 0.04 relatively easy. I think everyone's going to know what we're going to get there. We have to remember that negative 0.75 plus negative 0.75 is like, you know, going down and then going down again. So how far do you go down? Well, you go down the total amount plus the total amount again. So what you do when you have negative 7.5 doom plus negative, again, 0.75, is you add them together, and where you'll end up on the number line is negative 1.50. So you add them together and carry forward the negative sign. You add them together and carry forward the negative sign, and you will get negative 1.5 for negative 0.75 plus negative 0.75, and you'll get 0.8 for 0.4 plus 0.4. Wow, we still have a lot of work to do. Now, what do we do? How do we go forward now? We have negative 0.8, I'm sorry, positive 0.8 plus negative 1.5. So if we draw it out on the number line, and I guess we'll just use this number line again. We have positive 0.8, so that's there. That's positive 0.8, and we have minus, so up to 0.8, and then minus 1.5. And where do we end up? Where do we end up after we go up 0.8 and then down 1.5? Well, as we know, the first 0.8 of this 1.5 will be used to get back to 0, right? So the first 0.8 of this 1.5 will be used to get back to 0. So how much of this 1.5, this negative 1.5, do we have left? Well, what's the difference? What's 1.5 minus 0.8? We do that, we get 0.7. So we know we have 0.7 left to go negative. We start out at 0.8 positive. We lose 1.5. The first 0.8 of that 1.5 gets us back to 0. And how much do we have left to travel negative? We have 0.7 left to travel negative. So our answer is we're going to end up in the negative zone. We're going to end up at negative 0.07. And if we flip way back to our answer choices, here we go. It's B. We're good to go. Okay, question 9. A scientist uses a submarine to study ocean life. How fascinating. She begins at sea level, which is at an elevation of 0 feet. Okay, well, you know, whenever we have a submarine problem, let's just start drawing it out. So there we go, a little submarine. Starts out at 0. And what do we have? She travels straight down for 90 seconds at a speed of 3.5 feet per second. She then travels directly up for 30 seconds at a speed of 2.2 feet per second. All right, so there we go. 3.5 feet per second for 90 seconds down. For 90 seconds down, 90 seconds down, 3.5 feet per second, then up for 30 seconds at 2.2 feet per second. Okay, so 90 seconds down at 3.5 feet per second, then 30 seconds up at 2.2 feet per second. So what are we doing here? We are going to cross multiply to find out if you go down at 3.5 feet per second, how far you go down after 90 seconds if you travel at that rate. Okay, so we know how to cross multiply, right? We just do 3.5 times 90 and divide by 1, because you cross multiply and divide. What do you get? You get 315. So you travel down 315 feet. And then you travel up. How far did you travel up? You again just cross multiply and divide. You do 2.2 feet per second is how many feet in 30 seconds. You do 2.2 times 30 divided by 1. And what do you get? You get 66. So you traveled down 315 and you traveled back up 66. If you're dealing with negatives, it can get really confusing, but if you draw it out, it's as clear as day. You travel down 315, then up 66. What is this distance left to go? This distance left to go is 315 minus 66, or 249. You have 249 left to go to get back to sea level. And why is that important? Well, let's read on. After this 120-second period where you go down and then back up, down for 90, up for 30, how much time in seconds will it take for the scientists to travel back to the sea level at the submarine's maximum speed of 4.8 feet per second? So you travel down 315 feet, you travel back up 66 feet, you are 249 feet left to go from where you are to the ocean, to sea level. And you want to travel that 249 feet in the submarine's maximum speed of 4.8 feet per second. I don't know if this is like a horror movie or something terrible happened and you have to really get back, or maybe you made a great discovery. I don't know, but you really want to go fast for that last 249 feet. Well, and we just did this. 315 minus 66 is 249. So you want to go in that last 249 feet. You want to go super quick. You want to go 4.8 feet per second. Again, set up a proportion and just do the cross multiplication. You know, 4.8 feet per 1 second is going to be how many seconds for 249 feet. You just cross multiply and divide. 1 times 249 divided by 4.8. Plug it in your calculator and you get 51.875. So that's as many seconds as it's going to take. It's going to take 51 seconds, 0.875. That'll be a scary almost minute while you're racing back to sea level. And it says round your answer to the nearest tenth of a second. So rounded to a nearest tenth of a second would be 51.9 seconds. And that is your final answer. We're good to go. Okay, question 10. Graham's monthly bank statement showed the following deposits and withdrawals. And then you have a bunch of numbers. And then it says, if Graham's balance in the account was $47.86 at the beginning of the month, what was the account balance at the end of the month? So this is at the beginning, 47.86 is at the beginning, and then you add up all these numbers, and then you're going to get a final number. And that's pretty simple. We've done some really tough math in this packet. This is kind of simple because you're going to have a calculator and you really don't even need one because you have all these numbers and you just got to plug them in and do some adding and subtracting and you'll get to where you need to be. That being said, I think one of the reasons why the test makers included this question is because at this point in the test, you will have been working for a couple days. You'll be really burnt out. It'll be really, really tough. And you'll be totally done with doing all kinds of math and you'll just be done with it. And at that time, you're going to have to show some perseverance and you're going to have to show some attention to detail or precision. So perseverance and precision to get through to the exact right number in this problem. And that's really what this question is testing. It's not testing so much your ability to add decimals because they know you know how to do that from 4th, 5th, and 6th grade. It's really testing your ability to stay precise and to persevere to get the right answer after a big, long test. And you know, if you just add all the numbers together, you can, get all the positives and get all the negatives side by side if you want. You can do all the math a bunch of different ways, but at the end of the day, your final answer is going to be, and you should go through the steps and show each step you take. There's many different routes to get there. Because of the commutative property, you can add them up in different ways, but your final answer is going to be 138.98. And here we are, question 11. Trent is fishing from a pier. Good for you, Trent. The tip of his fishing rod is 53 3/4 feet above the surface of the water. The hook at the end of the fishing line is directly below the tip of the fishing rod, 12 2/3 feet below the surface of the water. So, all right, here we go. You're a guy, you're fishing. The tip of your fishing rod is 53 3/4 feet above the water, and the hook at the end of your fishing line hook is 12 2/3 feet below the water. Trent estimates that the distance between the tip, so the distance between the tip of his fishing rod, a la Bing, and the hook, Bing, that distance is less than 65 feet. Well, you know it's going to be around 65 feet, right? Because 53 feet plus 12 feet is 65 feet. But Trent, and this is a very common thing for a fisherman to do, right? Because obviously this really matters. But the estimate is it's less than 65 feet. And the question is Trent's estimate reasonable? Explain your answer. And if you say, well, it's going to be around 65 feet, but what do we do with the 3/4 and the 2/3? Well, if we add these numbers, we're going to add the fractional components too, and it's clearly not going to be reasonable. Again, a key part of this question is to actually read what the question is asking. The question is not asking, is 65 a reasonable estimate? It's, is less than 65 a reasonable estimate? And the answer is no. And this is how I would say it. Trent's estimate is not reasonable. The distance is more than 65 feet. 53 plus 12 equals 65, so more than 63 plus more than 12 will equal more than 65. And I've seen other students word it even better by saying they forgot to add the fractions, or the fractional parts will make it more, but the answer is no. Trent's estimate is not reasonable. Okay, on to the second part. Trent lets his hook drop another 10 inches. What is the distance in feet? Oh my gosh, curveball here. Inches, feet. Inches and feet. What is the distance in feet between the tip of the fishing rod and the hook? Do not round your answer. Okay, so here we go. We had 53 3/4 plus 12 2/3, and now we have another 10 inches. But this is feet and this is feet, so we got to make 10 inches into a foot, and we'll just make it 10 over 12 feet. This is a feet and this is feet. And that makes sense, right? 10 inches is going to be if there's 1 inch per foot, just like we did minutes per hour, is going to be 10 over 12 feet, right? I mean, you can think about in a tape diagram. You can say, well, this is 1 foot, and 1 foot is equal to 12 inches. So if you have 10 inches, that's going to equal 10 out of 12 feet. 1 foot is equal to 12 inches. And if you have 10 inches, you have 10 to 12 feet. 10 out of 12, or 10/12 of a foot. All right, so now we got to add them all together. We just simply got to add these three numbers together. We have 53 and 3/4. We have 12 and 2/3, and we have 10 out of 12. Okay, well, how do we add these numbers together? Well, we need a common denominator. So let's turn 3/4 into something over 12, 2/3 into something over 12, and 10/12 is good to go as 10/12. This will be 53, and this will be 12. 2/3, 3 times 4 gets you 12, so we're going to multiply 2 times 4, we're going to get 8. And 4 times 3 gets you 12, so we're going to multiply 3 times 3, we're going to get 9. And there we go. We're going to have 9/12 plus 8/12 plus 10/12. 9 plus 8 is 17, plus 10 is 27/12. And we're going to have 53 plus 12 is going to get us 65. So 65 and 27/12 is our answer. But we're like, oh no, we're not done, because 27 over 12 is an improper fraction. We have a mixed number with an improper fraction, and that just doesn't work. That's just not how we, present numbers. So what are we going to do? Well, if we think of 27/12, if we think of that as 12/12, which is a 1, and another 12/12, which is another 1. That's 24 over 12. We have 3/12 left, right? Because 12 plus 12 is 24, plus 3 is 27. So this is a 1, this is a 1. 65 plus 1 is 67. Because 12/12 is a 1, 12/12 is a 1. 65 plus 1 is 67, and 3/12. And if we take 67 and 3/12, we can just divide by 3 to simplify it, and get 67 and 1/4 inches, or feet, which will be our final answer, 67 and 1/4 feet.